So how many of you have taken my class in the spring semester? Raise your hand. So about, I guess, a little bit over half. So probably you know about the class styles, right? So after the class, I'm going to upload the lecture note on YouTube. So you can find my ID is David An. And then you can find the class under the title of Engineering Mathematics 2 dash 1, 2, etc., etc. Sometimes there's a previous lecture, maybe up to 14, I think, if my memory serves. And this year, I'm going to put the same with Engineering Mathematics 1 with 2022. So maybe a little bit updated from previous ones, but most likely very similar in terms of content. And unlike the online class, I seldom check the attendance. So if you don't like, you don't actually have to attend the class itself, because you can always check the YouTube class as well. But occasionally, I'm going to substitute the attendance by unannounced quiz. So attendance is 출석, right? It's going to be replaced by unannounced quiz. So if you were absent for the unannounced quiz, but that's it. If you are here, that's better. So they usually cover about maybe 10% of the total score, up to 10%. And we have the regular quiz, about 2-hour quiz. I think maybe it comprises over 3 times, 3 or 4. That covers about 70%, and one final, 3-hour final, about 30% for the total grade. I'm a bit strict about A+, about 10% gets A+. So that is your total score has to be over 90%, and your rank within 10%. So sometimes 10%, maybe less. So the maximum is about 10% of you will get A+. And as for the A, I'm a bit lenient. So usually about 30 to 35% gets an A. Because in the English class, you don't have to be strict about your relative rank. So I can give you a little bit more, but that's about it. And I think there is a bonus. usually at the end of the semester, around maybe end of November or beginning of December, there is the university-wise the math competition. Math competition is called, how should I say, in Korean, 공학 수학 경시대회. So if you get prize, you will get additional scores. So the first prize we have 89 students so far. First prize, I will give you 100 points. Second prize, 50. 대상, 금상, 은상인가? 세 개인가? I think the first prize is called 대상 and 금상. 대상, 금상, 장려상. Okay. So maybe the first prize will get additional 150. Second prize, 100 points. Third prize, 50 points. And if you just participate, you will get, I'll give you 20 points. Participate means just 참가. So, I mean, you just participate in engineering math competition. Even though even though you won't get the prize, you still get the 20 points. And if you get the first prize, you will get 150. Second prize 100, and third prize is 장려상, you will 50. So 2-hour quiz usually covers around 600 points. Final about 300 points. So actually 150 points is quite a bit. So I hope some of you get the prize. And traditionally, 1 or 2 students from my class usually get the prize. So if you get the prize, that will be helpful. And I think starting this week to next week is, how should I say, you can change the class, right? 변경 시간. So if you think my class is too strict about the grade, or maybe too rigorous, maybe you can change your mind and then change it to other class. So maybe you can make a wise choice. So any other questions? Let me see. So most of the students is from the engineering, the electronics department. And let me see. There's one student from English literature. 표성은? Here? So any reason that you are taking this class? You can answer me in Korean. Have you taken the calculus? 미적분학? 미적분. Have you taken 미적분? Okay. Konstantinopla, Julia. You are exchange student, right? So, have you taken calculus? Integration and differentiation class before?
No, I had maths in my home university.
So that covers the integration or differentiation?
Yeah.
Calculus? Okay, June and then program. But Mr. Hernandez? Jose Luis, right?
Yeah, that's good.
So, you also have taken calculus?
Yeah.
As a, okay, that's great. Because in the previously, some of the exchange students haven't taken calculus and have some difficulties. So I hope you won't have that. And sometimes I found that it happens in every few years that students took my class, take all the exams onto the final, and unfortunately their name was not in the list. So he or she couldn't get a grade. That happens a few times. So I want you to check your name when we have the recess. So I put the name list over there. So when you take a break, you can check whether your name and you can mark. If your name is not, just let me know or let my students know. Email tahnUSAC.kr. My name is Doyle An. So if you have any questions, you can send to email. And I don't know. So if you have any particular questions or if you need to consult something, you can send to email. Oops. I don't know how to remove this page. So the first part of this semester, we will cover vector analysis. So I guess you know the difference between the scalar and vector. Scalar is some function or quantity that has a magnitude only. Quantity or function with magnitude only. A vector, on the other hand, is you can say quantity or function with magnitude and direction. So you need something to indicate which direction you are taking. So that means you need something indicate the direction. And in order to indicate the direction, we need a coordinate system. That means you need a coordinate system. So coordinate is called 좌표계. One of the easiest way is right and left, right? Direction. So this monitor is on the left side of me, and you are in front of me, and screen is behind me, right? That's one of the ways to indicate the direction. But what you need, actually what you need is a common reference. And one of the easiest way or common way of defining the reference is using three mutually perpendicular axes called X, Y, Z. So three mutually perpendicular axis called X, Y, Z. And the center of the reference we call origin or O. This is called Cartesian coordinate system. So Cartesian coordinate system has been actually derived from the person, mathematician, who invented this coordinate, Descartes. In his book, Analysis Mathematique. In, I think, 18th century, 17 something. So about 300 years ago, the French mathematician, Descartes, invented the coordinate system. And since then, we call this particular coordinate system the Cartesian coordinate. So far, there are 19 different coordinate systems. And we are going to learn 2 more, and probably 3 more. Coordinate and spherical coordinate. I just put with dot to denote coordinate as an acronym, abbreviation. You may have little difficulty to decipher my handwriting in the beginning, but I hope you will get used to it. How many of you are taking electromagnetic theory, 전자기학? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So actually, the electromagnetic theory also begins with vector analysis. So maybe it may be beneficial for you to study my class. So we are going to cover Cartesian coordinate and cylindrical coordinate and spherical coordinate. Those are called curvilinear coordinate. So cylindrical coordinate and Cartesian coordinate, the spherical coordinates are also basis of electromagnetic theory, because you need to analyze the electric field and magnetic field in those three different systems. Am I going too fast? Or about the right time? Or too slow? No answer? Or you don't know? Okay, because of today's first class, I'll try to go as slowly as possible. And also you need to get adjusted to my English, so I'll try to speak as slowly as possible. But sometimes I might go a little faster. So no questions so far? Okay, good. I guess. So we are going to define the unit vector with the hat. So x is a unit vector in the x direction with unit magnitude. So how can you define the magnitude? You need to be a little bit patient, so I'm going to go that point a little later, but for now you need to have a phase. So y factor hat is a unit vector in the y direction with unit magnitude z, unit vector in the z direction with unit magnitude. That means we are going to define, this is the magnitude of vector dot. And we need to have a definition for the magnitude later, but let's just say x, y, z is equal to 1. So unit means 1. Also in mathematical knowledge, null means 0. No, null means 0. So null vector means 0 vector. Happen to be in Korean too. When you say 널널하다, that means I have 0 things to do. I do not know the origin of that particular phrase, but you know that phrase, right? 널널하다. That is, you have 0 things to do. The null vector, 0 vector. So how can you define the vector with this particular notation? That is, are you still copying? You have to live with that. So I accidentally inserted a the empty page in my lecture note, and I don't know how to delete that. There may be a way, but so we have some particular vector called A. So we call A vector as AX, X, AY, Y, AZ, Z. So if we project this A vector on the Z-axis, that is AZ. And if we project this into A-axis, it's not very easy to see, but assuming that you can project, that is AX, AY. But Z-axis is easy to see. You see the projection, right? The same way, if you have a B vector, BXX, BYY, BZZ. Then you can add to these vectors. Property number 1, 2 vectors can be added. So A plus B, AXX, AYY, AZZ, plus BXX, BYY, BZZ, then you can use a unit vector as a common quantity and then put the parentheses, put them together. So AX plus BX with the X, AY plus BY, Y, AZ plus BZ, Z. Okay, before I forget, I will figure it out later. And secondly, vector can be multiplied by a constant. That means CA, C times AXX, AYY, AZZ is equal to CAXX, CAYY, CAZZ. So 2 vectors can be added, and vectors can be multiplied by the constant. So any quantity that forms these 2 particular properties from a vector space. So this is actually essential definition of a vector space. So the Cartesian vectors definitely form a vector space. Vectors can be multiplied. As well. So if you have 2 vectors A, B, and their angle, there are 2 ways of forming a vector multiplication. One is inner product. A dot B, magnitude of A, magnitude of B, cosine theta. And magnitude is defined as square root of A dot A. That's the definition. So before doing that, let's start with the unit vector. So x with x. So what is the angle between x hat and x hat? Theta is equal to? If you have one vector and the same vector, what is the angle? 0, right? So there's x cosine 0. Cosine 0 equal to 1, right? So it's equal to 1. So cosine 0 is 1. X dot y cosine pi over 2. So cosine pi over 2 is 0, right? So this is 0. X dot z, again 0, right? X z is 0. Y dot y, 1, right? Y dot z, 0. So we have all the different cases. I guess we covered that. So A dot B is actually AX x, AY y, AZ z, dot BX x, BY y, BZ z, AX BX x dot x, AX BY x dot y, AX BZ x dot z, right? Plus AY BX y dot x, AY BY y dot y, AYBZ y dot z. I may have to write the small letter. AZ BX z dot x, AZ BY c dot y, AZ BZ z dot c. So this goes to 0, right? 0, 0, 0, 0, 0. So everything goes here as AX, BX, AY, BY, AZ, BZ. So So possible quiz problem is as follows. All right, can I move to next page? So we have a 1x plus 1y plus 1z, and there is b minus x plus y plus z. And what is theta? So a, the magnitude of a is what? Square root of 1 plus 1 plus 1, right? Square root of 3. How about b? Square root of minus 1 square plus 1 square, again root 3. A dot b, minus 1 times 1 plus 1 times 1, 1 times 1, 1, right? Because these two cancel each other. I mean ax, bx, ay, by, az, bz. So a dot b is 1 square root of 3 cosine theta. So cosine theta is 1 over 3. Theta is cosine inverse 1 over 3. So that means in the quiz you might need a calculator. To calculate this kind of things. Okay. Second type of multiplication is called the vector product. I will let you copy the screen. So we have only, how many? So we have 3 different screens, right? Great. Second type of multiplication is called the vector product. So basically it follows the left-hand rule. A, B, A cross B. This way. So A, B, A cross B. So A cross B this is your theta. So basically this is the area. expand by A and B. So let's again starting with the unit vectors. So x cross x. So what is the angle between x and x? Sine 0. So sine 0 is 0, right? X cross y. So following the left-hand rule, then direction is what? Perpendicular to x and y plane is z. And the angle is, the angle between x and y is pi over 2, or 90 degrees. So sine pi over 2 is equal to 1. So this is C. X cross Z. It's a little bit tricky. So you have to put this way, right? X, right? X cross Z. Then direction must be? This is Y. You have X. This is Y. Actually, X, Y, Z, right? And I twist it such that this way. Actually, I have to put this way, right? X, Z. No. X, Z. This is minus Y. So I will put the following simple way. If we go this counterclockwise, we have plus sign. So we have pointer. We don't have a pointer. Okay, next time I will try to bring the pointer, but is there anything? Okay. So you have to use your imagination. You use your imaginary hand. So this x, y goes to z, right? Now you need to have x cross z. This way. Minus y. Y cross z, you have y, z, x. Counterclockwise, you have plus. Clockwise, minus. No. This is all wrong. This way, minus. Z cross x. Z cross x gives y, right? Z cross y. Z cross Y. Z cross Y. Minus X, right? So I summarize. The basic rule is follow this. If this is plus. Minus. So x cross x is equal to 0. X plus y is equal to xy equal to z, right? X cross z minus y. Y cross x minus c. Y cross y, 0. Y cross z, x. Z cross x, y. Z cross y, let me say z cross x, y. Z cross y minus x, right? Z cross z, 0. So then A cross B can be calculated as AXX, AYY, AZZ cross PXX, PYY, PZZ. So maybe before burning your brain, maybe we can take a few minutes break. Okay, say, because it'll take maybe about 5 to 10 minutes. So I'm going to take a 5 minutes break. 휴식 시간 5 minutes. And meantime, you can check whether your name is on the list. So we will get here 10:55. 이름 있으면 체크해 놓으세요, PC. 혹시 마스크 쓰고 수업하는데 내 발음 괜찮아? 들려요? 이상하게 들리진 않아요? 좀 웅얼웅얼하게 들릴 수도 있을 것 같아서. So before proceeding to the next class, is there anyone name is not on the list? 자기 이름이 없는 사람은 들어볼게요. 제대로 다 수강시청 거죠? 딱 한 번만 체크할까요? 이번 오늘만. 그래서 한 번 더. 자기 이름이 없는 사람. So you checked your name on the list. Great. So I don't have to worry about you being not listed at after the final exam. So let's continue the discussion about this vector product. So A cross B. So you have to multiply two vectors term by term. So start with AX, BX, X cross X, AX, BY, X cross Y, AX, BZ, X cross Z, plus AY, BX, Y cross X, AY, BY, Y cross Y, AY, BZ, Y cross Z, plus AZ, BX, Z cross X, AZ, BY, Z cross Y, AZ, BZ, Z cross Z. So let's start with zero terms. So let's get rid of the zero terms. So X cross X, 0, right? Y cross Y, 0. Z cross 0, 0. X cross Z, X cross Z, X cross Y. So you start with X, Y, you get Z, right? So this is plus Z. How about X cross Z? Minus Y, right? Y cross X. Minus Z, right? Y cross Z. Y cross Z. X, Y, Z. Y cross X, right? Z cross X. Y. Very good. Z cross Y? Minus X. Very good. So you are getting very good. So let's get together with the X term. So we have how many X? AY, BZ, right? Minus AZ, BY plus Y, Where is y? Y. AZBX, right? Minus AZBX. Oh, this is AX. AX BZ plus C. Where is Z? Z. AX BY, right? Minus AY BX. So I'm going to move this to this one. Oops. I was trying to cut and paste, but I think I have forgot. So I just do it the old-fashioned way. So paired with the previous x, y, z, cy, y, z, x, right? So same expression. If the permutation is in counterclockwise, we have plus. Clockwise permutation, you give minus. So A cross B, X, AY, BZ minus AZ, BY plus Y, AZ, BX minus AX, BZ plus Z. AX, BY minus AY, BX. Let me check my short-term memory is still good. So you can see this X, Y, Z. In the counterclockwise direction, you get positive number. And on the other hand, if you have this X, CY, you have minus. Same goes with Y, ZX plus, Y, XZ, you have minus, right? Z, XY plus, Z, YX minus. So this can be actually expressed as a determinant if you still remember what you have learned in the spring semester about third week or second week. You can put this way. I hope you do remember the determinant. How many of you remember determinant? 3 by 3. Very good. So more than half of you remember determinant. This is very good. Otherwise, you can just memorize this. But there is another way of representing this. I didn't turn off the recording during the break, so the questions about asking you whether your name is on the list or blah blah blah, all recorded. It's my fault. So if I put the YouTube, all those gibberish will be also in the YouTube. And I seldom, I don't bother to edit. I just put it as it is. Another way, if there is a very neat way of representing this vector product or determinant is using. So you can see that x component AY BC minus AZ BY, right? So instead of writing this, you can just use one symbol. Let's check with the other component too. Just make sure that you understand. Right? Same as this. AZ BX minus AX BZ. And so the final component, 1, 2, right? AX BY minus AY BX. So we just found that very powerful symbol. Epsilon ijk. So ijk either 1, 2, 3, or you can put x, y, z. So even permutation, odd permutation, otherwise. So for now, let's just put x is equal to 1, y equal to 2, z equal to 3 for convenience. Actually, you can use x, y, z, but it doesn't matter. But it's more convenient just use numbers 1 to 3 to work with the Levi-Civita symbol. So, for example, we have 1, 2, 3 in this counterclockwise direction. It's called even permutation. Actually, you probably have learned about this Levi-Civita symbol in the spring semester, right? But anybody remembers this symbol? Or have anybody has seen the symbol? So you are as good as new, right? Odd permutation minus 1. So for example, epsilon 1, 2, 3 is 1 or minus 1? 1, right? Epsilon 2, 3, 1. 2, 3, 1? 1, right? Epsilon 3, 1, 2? 1, right? Epsilon 3, 2, 1. Odd, minus 1. Epsilon 2, 1, 3. Minus 1. Epsilon 1, 3, 2. Minus 1. Epsilon 1, 1, 2. 0. So 3 number has to be different. Etc., etc., etc. So using this, So I think this notation you need time to get familiar with. So I will try to do as slowly as possible. And so A cross B, I's component is sum over J, K, epsilon, I, J, K, A, J, B, K. Definition is follows. So let's say, example, A cross B, first component. This is actually A cross B, same as X component. So we promised to each other that X denote 1, or 1 denote X, 2 denote Y, Z denotes 3 denotes Z, right? So that is JK epsilon 1 JK AJ BK. But there is one constraint. J and K are different and different from 1, right? So epsilon ijk has to be all 3 digits, 3 component has to be different. Since we have fixed 1 already, because we are checking the first component, epsilon, we have fixed 1. So jk has to be different from 1. So we have only 2 possible cases. So possible cases, j equal to 2 and k equal to 3, right? Or j equal to 3 and k equal to 2, right? So we have only 2 cases. So actually this summation is like this. Epsilon 1, 2, 3, A2, B3, plus epsilon 1, 3, 2, A3, B2, right? So epsilon 1, 2, 3 is plus 1. Epsilon 1, 3, 2, minus 1, right? So this is basically A2, B3 minus A3, B2. So if you convert 2 to Y, 3 to Z, then it becomes AY, BZ minus AZ, BY. So compare with this result with the previous case. So AY, BZ minus AZ, BY. Let's compare with the previous case. The second component, you can do the same thing. Result. Classical method. A cross B, Y, the same as actually A cross B, second component, right? So the same thing, J and K, epsilon 2 JK, AJ BK. since we have fixed the first component as equal to 2, and j and k has to be different to each other and also different from 2. So j and k can be either 1, 3 or 3, 1, right? So we have j equal to 3, k equal to 1, or j equal to 1, k equal to 3. Two different cases only, right? So epsilon 2, 3, 1, a3, b1 plus epsilon 2, 1, 3, a1, b3. So 1, 2, 3, this is plus. 1, 2, 3, this is minus. So 2, 3, 1 plus, right? So this is plus 1. This is 2, 1, 3 minus 1. So we have a3, b1 minus a1, b3. Or if you convert it back to xyz notation, what do you get? az bx minus ax bz. That's your y component. And again, we can check with the direct multiplication. So y component is az bx minus ax bz. Let's check with the There is an old saying that 3 times make it perfect. So let's just do one more example. That you can define A cross B Z, same as we can put as 3, right? So this is JK epsilon 3JK AJBK. So now the first component is fixed to be 3. So what choices do we have for JK? 1 and 2, right? So J can be 1, K is equal to 2, or J is equal to 2, K is equal to 1. That's the only choice, right? Other choices you will get zeros. So we have two choices, J equal to 1, K equal to 2, or J equal to 2, K equal to 1. So this is the only possible choices we have. Epsilon 3, 1, 2, A1, B2 minus plus epsilon 3, 2, 1, A2, B1, right? Again, 1, 2, 3, this gives plus 1. 1, 2, 3, this gives minus 1. So 3, 1, 2, but 3, 1, 2 is equal to plus 1. 3, 2, 1? Minus 1. Very, very interesting. A1, B2 minus A2, B1. So AX, BY minus AY, BX. And let's compare with the previous one. The vector product, we can conclude that A cross B I component is JK, AJBK, epsilon IJK. So they are basically the same as just we find the result by crossing two vectors together and then calculate the component by component the vector product terms. But you can just write in just one single line to get the whole result. But why? Why bother? Because this epsilon Levi-Civita symbol is a very abstract thinking. But is there any possible merit? So you can ask, why bother? Right? You can calculate the vector product still, just multiply by two vectors. And of course you have 9 components, but you can still get term by term. Of course, it looks convenient if you use this Levi-Civita symbol in one line, but why? That is, when you have complicated cases, such as this, epsilon times b, you have 3 vector products. Then the Levi-Civita symbol gives you a very powerful method. So assuming that you have I components, then you can do the same thing. jk, right? Epsilon I jk aj and b cross c k component, right? Then we have jk epsilon I jk aj. We have pq epsilon k pq pp cq. jk pq epsilon I jk epsilon k pq aj pp cq. I have to figure out how to make a cut and paste. I think I used to know how to do that, but I haven't done it for a while. So naturally I forgot. So I'll just make a copy again. A cross B cross C I. We have JK, we have a PQ, epsilon I JK, epsilon K PQ, AJ BP CQ. We have K as a common factor, right? And the product of two Levi-Civita symbols. So what you can do is we have J, P, Q, and we have K, epsilon I, J, K, epsilon K, P, Q, A, J, P, P, C, Q. Another interesting thing is this can be actually written as PQK. Because you have KPQ, start with KPQ, PQK, right? So from this, epsilon KPQ is same as epsilon PQK, epsilon q kp. And there is a relationship that k epsilon ijk epsilon pqk is delta ip delta jq minus delta iq delta jp. This delta symbol is it mine or? I think not mine. Delta ij is I equal to j. It's called Kronecker delta. Kronecker delta. So you learn two different mathematical symbols, Levi-Civita and Kronecker delta. I think Kronecker delta you have learned that. Remember in spring semester? Right? If you don't remember, then just learning the definition. So delta ij means 1 or 0 when I is equal to j is equal to 1 or otherwise is equal to 0. So let's check. Sum of k epsilon I j k epsilon p q k is basically k can be 1, 2, 3, right? So I j 1 epsilon p q 1 plus epsilon I j 2 epsilon p q 2 epsilon I j 3 epsilon p q 3. The first case, ij has to be 2 or 3, right? ij has to be 2 or 3 because we already fixed 1. So for non-zero, it has to be 2 or 3, right? So when I and p are the same, and j and q are the same, it is 1, right? When I is equal to q, p, j is equal to p. They are different permutations. So it's minus 1, right? So in this case, this is delta ip, delta jq, or delta iq, delta jp, right? Because ij has to be 2, 3. Pq has to be 2, 3, right? So I is 2, P is 2. J is 3, Q is 3. If in the same order, it's always 1, right? Or I is 2, when I is 2, J is 3, is 2, 3, 3, 2, 1. When I is 3, J is 2, 3, 2, 1 is equal to minus 1, right? But so is when P is 3, Q is 2, again minus 1. So when I and JP are the same, J and Q are the same, then regardless of whether this Levi-Civita is even or odd, it's always plus plus or minus minus equal to 1, right? But when they are different, when I is equal to Q and J are equal to P, then always one is positive, the other one is negative. So in this case, it's minus. For second case, the same. When k is equal to 2, ij has to be 1, 3. Pq has to be 1, 3, right? So when they are in the same order, then it's always plus plus or minus minus, you get same sign, plus. So in general, and same goes. So in general, so you have always delta IP, delta JQ minus delta IQ, delta JP. So this is a very interesting property of the product of a Levi-Civita symbol. So we have expression confusing? I mean, it may be confusing at the first moment, but you can check. Just sitting calmly and consider the different cases. Oh, so can I move to the next page? Let's move on. So we have A cross B cross C I J P Q sum of K epsilon I J K epsilon P Q K A J B P C Q, and this turns out to be J P Q delta IP delta JQ minus delta IQ delta JP. So P has to be I. So this is, you have J, A, J, B, I, C, J, right? P is equal to I, Q is equal to J, minus A is AJ, BJ, CI. BI, sum over J, AJ, CJ, minus CI, AJ, BJ, sum over J. This is what? A dot C, right? This is A dot B. So we can get A cross B cross C BAC minus C A B. Let me write it down. C A P. So Levi-Civita symbol, you can show this relationship in maybe few lines. So I will give you homework. Did I make a mistake? A, B. Oh, BAC minus CAB, right. So, mistake of sign. BAC minus CAB, so it has to be show that A cross B cross C, C A B minus B A C by multiplying A B explicitly. So you have to calculate how many components? 3 by 3 by 3 is 27 components, right? So 27 components. It may take about 1 hour. So you have to multiply B cross C first, and then multiply by A, right? So idea is you first define D as B cross C. So that is you have X, B, Y, C, Z minus B, Z, C, Y plus Y, B, Z, CX minus BX, CZ plus C, BX, CY, BY, CX, right? And then A cross D. So you need to have a 27 component, and then eventually we'll get the answer. And my definition of a homework is you do as you go. But you don't have to turn in. You don't have to sum it. Just do at your home. Do your work at home. So when I say homework, you just do at your home. For your own benefit, but don't turn in. We don't want to grade. 그러니까 내가 수업 시간에 호흡먹이라고 하면 집에서 해보는 거예요. 그냥 내진 마세요. 채점하기 귀찮으니까. But homework will help you to get a good grade. So when I ask you to do homework, do it at your home. So, at least you have seen one evidence that use of abstract methods such as the level-selected symbol can help you to simplify a lot of steps and like a 3 product. Or you can product have 4 different vector products as well. You can do the same thing. So why bother with a vector product is this is what? A, B, C, A, B minus B, A, C. B, 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 B. This has to be, I think, this has to be plus, this has to be minus, right? So in electromagnetic theory, we are dealing with a particular vector called del, which is defined as x partial, partial y partial, partial z by partial. Then there is electric field and magnetic field D is defined as so E is electric field, H is magnetic field, D is electric polarization, B is a magnetic polarization. J is current, rho is charge density. This is called Maxwell's equation. And three vector products comes in the following. For example, so at the end of the semester for your electromagnetic class, you will learn this Maxwell's equations. And so this is not the subject of this class, but maybe just your preview toward the end of your semester for the other class, electromagnetic theory. Then interesting thing is, so PAC. Okay. You can form a three vector product, which is actually then this is what? This is A, B, C, right? So CAB, BAC, ABC, BAC, minus CAB, right? CAB, so we have CAB minus BAC, BAC, cos H, partial D, J, minus epsilon nu, partial T, partial square E, minus nu, partial T, partial J. So something is easy. Let me see. This is minus, this is plus, this is minus, this is plus. Right. Equal to where is it? Minus type so this is actually called wave equation. So from Maxwell's equation, if we multiply by the their operator means more, you get the wave equation. That means we have electromagnetic wave propagating through the space. So this is one useful way of having three vector products to describe the properties of electric and magnetic field in another class. But for its own purpose, this Levi-Civita symbol operation is very convenient for you. And since today is the first class, maybe, and it's about lunchtime, I'm thinking about stopping here today. What do you think? And before I forget, on September 21, I have to go to an outside meeting, so I cannot have a class. So instead of having class, you can watch my YouTube class, Engineering Mathematics 3, 2-3. So September 21 is a Wednesday. Next 2 weeks from now, I will be out of town, so you will watch YouTube Engineering Mathematics 2-3. And no checking for the attendance, just watch the YouTube. Okay? So see you next week. Enjoy your lunch. And stay away from COVID.
마지막에 초록색으로 바꾸신 거 있잖아요.
네, 사인이 틀렸어요.
아, 잘못
네, 잘못 깎였어요.
감사합니다.
네. So your name?
Yeah, I know, but I have to take it.
Oh, it's okay. You can check your name. So where are you from? Mexico. Through the end of the you cannot read Korean yet?
No, not yet. I'm taking classes,
Oh.
so I don't do Korean yet.
Hernandez?
Jose.
Jose Luis.
Yeah, that's what it is.
The Spanish name, right?
Spanish name, yeah.
So you speak Spanish?
Yeah, I speak Spanish.
But English is okay.
Really?
Yeah.
Okay. Hopefully it's fine.
Right. So, do you have any trouble following my class?
No, I'm okay.
Uh-huh.
I can.
So were you in my class in the spring semester as well?
No, I've only arrived this semester.
Oh, I see.
Yeah.
So you have taken
Mathematics
Calculus.
before? Yeah, I have taken calculus.
And how about after that?
After that?
Linear algebra, matrix?
No, not really.
Not
Linear
really.
algebra. Matrices I have taken, but not linear algebra.
But you know how to calculate the determinant.
Yeah, I know how to do that. That's fine.
That's about you need.
That's what?
That's about you need.
Oh, really?
What you need. semester.
Okay, that's fine.
Okay. So if you have any trouble, just check with my YouTube classes.
YouTube channel. Yeah.
There are about 30 classes.
Okay.
All right. Good luck.
That's it. 감사합니다.
내가 시험 문제 내가 가르쳐 줄게. 내일 끝냈어.